Hello and welcome back to Fix My Maths. Today I'm going to help you master probability. Let's get started. Hello and
welcome back to the channel. Today we're breaking down one of the most tested GCSE math topics, probability. We're going to cover the basics and key formulas, frequency trees, Venn diagrams, and the tricky combined event questions that most students lose marks on. This is going to be my longest and most detailed video yet, so by the end you'll be fully exam ready. Let's get straight into it. The fundamentals. Probability is simply how likely an event is to actually happen, and the key formula you must know is probability equals number of desired outcomes divided by total number of possible outcomes. Here's the first example. I roll a fair 6-sided dice. What's the probability of me getting a 4? There's one favourable outcome here, and that's the number 4. And there's 6 other possibilities. So that's 1 of 6. Simple. Example 2. What's the probability of rolling an even number? Even numbers on the dice are 2, 4 and 6. That's 3 favourable outcomes. The total is still 6, so that's 3 of 6, which simplifies to a half. Now, something students always get wrong. Probability can never be less than 0 or greater than 1. 0 means impossible and 1 means certain. Anything in between expresses likelihood. And here's another one students often forget. If you list all outcomes of an event, their probability must add up to 1. Here's an example of that. A bag contains red, blue and green counters. If red equals 0.2 and blue equals 0.5, then green must equal 0.3, so it all adds up to 1. Talk about the probability scale. It looks like this. 0 equals impossible, 0.5 equally likely, and 1 equals certain. This scale is used a lot when questions ask you to place events or compare likelihoods. Now we also need to understand the difference between theoretical and experimental probability. Theoretical probability uses maths and logic. When you flip a coin, theoretically you can get heads half of the time, so P heads equals half. Experimental probability is based on data from real experiments. Example, if you flip a coin 100 times and get 62 heads, your experimental probability equals 62 out of 100, so 0.62. Here's the key rules for GCSEs. The more trials you do, the closer experimental probability gets to theoretical probability. This is called law of large numbers. Example questions, I love asking you to predict outcomes. If experimental probability of heads is 0.62 out of 100 trials, then in 250 flips, we expect 0.62 times 250, which equals 155 heads. Later, we'll go deeper into combined events, but for now, this is the fundamentals, is all you need to know. Frequency trees are one of the easiest ways to show probability. Let's say 200 students sit in a test. 120 of them are boys and 80 of them are girls. 60% of the boys pass and 75% of the girls pass. So you draw the tree. Boys 120, pass 72, fail 48. Girls 80, pass 60, fail 20. Now we can answer questions like, what's the probability a random chosen student passes? Total passes is 72 plus 60, which equals 132. Total students equals 200, so the probability of pass is 132 out of 200, which equals 0.66, or 66%. Frequency trees make combined events much easier.
For at least one questions, use 1 minus the probability of none. It saves loads of times.
We're going to look at Venn diagrams. These often appear on higher level GCSE papers. So let's go through an example. 100 people are surveyed. 40 of them like tea, 55 of them like coffee, and 20 of them like both. The intersection, we put 20. Tea only equals 40, so 40 take away 20 equals 20. Coffee only is 55, and then we take away the 20, which equals 35. Neither is 100. Take away 20 plus 35, which equals 25. Now the diagram is complete. You can answer questions like, what's the probability someone likes at least one drink? That means tea, coffee, or both. So add 20 plus 25 plus 35, which equals 75. So the probability would be 75 out of 100, which would be 0.75. Or what's the probability someone likes neither? Which would be 25 out of 100, or 0.25.
Always check if events are independent or dependent. It changes the whole method. Always check.
There are two types of combined events. independent events. One event does not affect the other. Here's an example. Roll a dice and flip a coin. The outcome of one doesn't change the other. Rule: multiply the probabilities. For example, rolling a 6 and getting heads. So it's 1/6 times 1/2, which equals 1/12. Another example. Choose a card, replace it, and choose again. It's independent. Dependent events. The first event does affect the second. Here's an example. A bag has 3 red counters and 2 blue. You take one out without replacing it, then pick again. Let's say the first counter is red. Now the bag has 2 red and 2 blue, so the probabilities have changed. Here's the rule. Multiply the probabilities, but use updated values for the second event. Here's an example. Red then blue. First red is 3/5, then blue, which is 2/4. So combined equals 3/5 times 2/4, which equals 6 out of 20, which also simplifies to 3/10. Here's another example. At least one. These always confuse students. The easiest method is to use the complement. At least 1 equals 1. P equals none. Example. 2 dice rolled, probability of getting at least 1/6. Instead of listing every case, do no 6 on the first die equals 5/6. No 6 on the second die equals 5/6. Because obviously, if you roll the dice, there's a 1 out of 6 chance of getting a 6. Multiply 25 by 36. So at least 1 is 6, which equals 1. Take away 25/36, which equals 11/36. It's much quicker. And there you have it. You've completed GCSE probability lessons. Everything from basics all the way to the tricky combined events. If this helped, please hit like so more GCSE students can see it. Subscribe if you want full guides for every topic, and let me know what you want next. Thanks for watching and good luck with your revision.